Tom Coleman and Sacha Greif, our first speaker, co-authored a book called Discover Meteor. Most of you have probably already heard of it if you've spent any time in the Meteorverse recently. And today, Sacha is going to show you an app called Dribbble as an exercise for an introduction to Meteor. Here's Sacha.
Hey, everybody. So as you can see from the title of this talk, this is going to be an introduction to Meteor. So it might be a little basic for some of you. Just so I know, like, are there any people here who are completely new to Meteor? Just show of hands. There's a few. So for the others, maybe you can play Angry Birds or, I don't know, or maybe you'll learn something. So the first question I want to address is simply, what's Meteor? So Meteor is a JavaScript framework. That's what I say when people ask me. But when I say that, most people think about stuff like Backbone or Ember, Angular. And basically, those are all client-side JavaScript framework, right? So in a traditional stack, you'd have like Ruby on the server or PHP, and then you have your JavaScript framework on the client. So then a couple years ago, we had Node. So Node is basically JavaScript on the server as well as on the client. But the thing is, even with this new stack, even though it's the same language, you're still dealing with like two different frameworks and two slightly different environments. And this is where Meteor comes in. So Meteor is basically a full-stack JavaScript framework with both server-side and a client-side component. And this is really cool for a bunch of reasons. First of all, you only have one language. You only have one API. Both sides, both components are made by the same team. So it's a much more cohesive environment. And from that architecture, you also have a lot of cool features. For example, all Meteor apps are single-page apps. So what I mean by single-page app is unlike, let's say, a Rails app where you would reload data and code on every new URL. On a Meteor app, you load all your code once on the first request, and then all subsequent requests will only need to request data. So that makes for much faster and more responsive apps, because loading just data is faster than just loading code plus data. Another very cool thing, and I think actually this is one of Meteor's biggest innovations, is what the Meteor team calls database everywhere. So what Meteor will do is it will take your server-side database and actually duplicate it on the client inside the browser's memory, either the whole database or most likely a subset of it. But what that means is, instead of doing a whole round trip from the client to the server to the database, now your data is already sitting there in the client. So again, it makes for much faster apps and a much better user experience. Finally, the last feature I want to talk about is reactivity. So like I just said, Meteor maintains a copy of your data in the browser. And whenever that data changes on the server, that browser copy will also be updated. What's more, if that client-side data changes, the data in the browser can optionally also be updated. So this is what we call reactivity, and that even extends to the UI. So any piece of UI that depends on your data will get updated at the same time. And by the way, all of this happens in real time. So this is the end of the boring part that everybody already knows. And now the the main content of this talk is going to be walking you through building a very simple Meteor app. So who knows this site? Yeah? So when I first gave this talk, it was for a design conference. So this is why I picked Dribbble. For those who don't know Dribbble, it's a site where designers can post their work, and other designers can comment or like those images. So what you're seeing here is the homepage of Dribbble, where there's a ranking of the most popular images of the moment. And here's what we're going to build. So it's a grid of the Dribbble homepage, and I call it Dribbble. And each column of the grid here is basically a snapshot of the homepage laid out vertically. So here, for example, this is the image in first position, second position, and so on. And each column, each of these snapshots is taken every hour. So the result is this really simple visualization, which lets you see the evolution of the homepage over time. So really simple, but it's actually pretty cool, I think. And this is how we'll go about building it. So what you have up there is a really high-level overview of the structure of the app. Basically, we have the Dribbble API, and every hour we'll make a query to that API, store the result inside our database, and this way, whenever a user comes and wants to check out our app, we can simply go to that database, retrieve the 12 latest snapshots, and bring that up in the UI. So the first step is going to be setting up Meteor. So I'm not actually going to do it, because I already have Meteor. But I wanted to show you how easy it is. It's just one line of code that you can copy-paste in your terminal and run. You can then create the app, open the app, run the app with Meteor. And that gives you the standard placeholder app created by the Meteor command. So I'll start by removing those placeholder files, creating 3 directories. So let me explain real quick what those directories do. So I mentioned before that Meteor is both on the client and the server. That's kind of what makes Meteor special. So that's why you have a client and a server directory. And anything you put in that client directory will only get loaded and executed on the client, so inside the browser. And similarly, anything you put in the server directory will only get loaded and executed on the server. Finally, the collections directory you have there, since it's not client or server, it will actually be loaded and executed in both environments. So this is kind of a very simple but very flexible way of controlling your app's scalability and security. For example, if you have sensitive data like API keys, you can safely store them in the server directory, and you know they will never be transmitted to a client. OK, so we'll copy-paste a style sheet in that client directory. And you'll see that the app immediately updates. And what's really cool is that the style sheet will automatically get injected. So Meteor is watching your directory, and if it picks up a style sheet or a JavaScript file, it will just add it. OK, so the next step will be collecting data. So taking data from the Dribbble API and inserting it in our database. To do this, we'll declare a collection. So that's what the syntax looks like. Snapshots equals new Meteor collection. And then the argument we pass here will be the name of the collection inside our MongoDB database. By the way, you'll notice this file lives in the collections directory. So like I said, it's going to be included in both the server and the client. And that's pretty cool because this means both will have access to our data. The next step will be adding the HTTP package. And we'll need it right now. So what you have here, first is the URL that we're going to query, the URL of the Dribbble API. Then we can declare our query API function. And this is where the HTTP package we just added comes in. So we'll make an HTTP GET call to that Dribbble API URL, take the result, add a timestamp to that result, and finally insert the whole thing in the collection we defined. So this is how we insert data in our database, collection.insert. Really simple. OK, so what we want is these snapshots running every hour. And this is exactly what we're doing here with set interval, which takes a function and then runs it every 3,600,000 milliseconds, in other words, 1 hour. So we'll just wait a couple hours and see what happens. So maybe you can come back tomorrow morning. Or OK, I did preload some data. So we can actually move on to the fun part, displaying that data. So we'll have 3 templates. So templates are basically blocks of reusable HTML. So rather than have all of our markup in a single file, we'll split up our app to be a little more modular. The first one here will be the main template. And that's where Meteor stores the markup that will act as the wrapper for your whole app. So this is just simple HTML. First, we have a head tag with a title. And by the way, you might be wondering why we don't have a doc type or a link tag, script tags. Well, all of these will get inserted by Meteor automatically. So we're free to focus on the more important stuff. The second part here, you might be wondering what that tag is. Well, it's a template include tag. So it's telling Meteor to replace that tag with the grid template. So the next step will be building that template. So again, this is the template, the one that's going to hold our main grid. And before I go any further, I just want to give you a real quick detail about the data we're working with. So our collection is called snapshots, and this is what a single snapshot looks like. So we have a timestamp, and we have a data object, which is the data we got from the Dribbble API. Inside that data object, we have a shots array. And each shots, which is Dribble's term for images, by the way. So each shot has a title, URL, and image teaser URL. So this is what our grid template looks like. Up there, first, we have our template tag, which tells Meteor that this is a template, and it's named grid. And then we have a loop over snapshots. So we haven't defined snapshots yet, but it will contain the 12 latest snapshots which we get from our collection. So if you remember the data structure we just looked at, each of those snapshots had a timestamp, and this is what we're going to display. And before I move any further, I just want to talk real quick about data context. So we just saw a template, which is what I have represented here. And a template is basically like a mask that you can put on top of something else. In this case, data. And what's important to understand is that you can apply a template to different data contexts, or the other way around, you can apply different templates to the same data context. So it's kind of having a pie with different kinds of fillings, or in this case, the pie would be the template, and data context is, let's say, apples or banana, maybe. So the reason why I want to talk about this is because our next step will be providing that data context, so our template knows what to display. To do that, we'll use this syntax. So find is Meteor's, or rather MongoDB's, way of querying data and getting results. It takes 2 arguments. The first one is the selector, which indicates what kind of data we want. And the second one is the options, which lets you sort or limit the number of results. So we'll use this in our snapshots helper. So template helpers are one of the ways you can provide a data context, and that's what we're going to do. So up there here, you can see we're defining a helper for the grid template. That helper is going to be called snapshots, and it's going to take a function, and whatever that function returns is going to be our data context, or the value of our snapshots helper. So we query the collection, the snapshots collection. First argument is an empty object. Now, the reason we pass an empty object is because we don't have any special requirements on our data. We just want to take all of it, although we will sort it and limit it. And when we run all this, we see our timestamps. So the reason they're all jumbled in here is because they're Unix timestamps with a lot of characters. But at least we can verify that our data is flowing from the server, where we store that data, to the client, where we're displaying it. So, but what we actually want to do is not display the timestamps, but display the actual data from each shots. So this is why we first have an each loop for the columns, and then a second loop for the rows. Finally, for each iteration of the loop, we're displaying a title. OK, it's starting to look more like the finished product. And now the last step, which is good because I only have 10 seconds left, is the shot. So the shot template will be very simple. There will be 2 placeholders, URL and image teaser URL. And these placeholders will get their value from snapshots. So what's really cool is we don't need to redefine helpers. Meteor is smart enough to look into the snapshot we already defined. Finally, we can, whoops, this one is not in the right spot. Anyway, just imagine that the shot thing there is highlighted. And we can include that template. And we have our app. So the reason this is a little rushed is because there's actually more to it. But what I will do is record a screencast of the whole thing, and it will be available online. So in the meantime, if we have time for questions, maybe, or yeah.
Yeah. Please repeat the questions.
Or should I go on, maybe? How are we for time?
Let's see. We can take about 5 minutes for questions. So yeah.
OK, or so either questions or I keep on talking, your choice. OK. So I'll try to finish this briefly. The last part of this thing is controlling data. So yeah, we need to talk about this auto-publish thing. So before I said that Meteor will automatically take the data that's sitting on your server and send it over to the client. And that works well when you're prototyping an app, getting started, but it's not a very scalable approach, because when you'll have 10,000 or 100,000 records in your database, you can't afford to just send over all of that to every single connected client. So this is exactly what auto-publish does. It just sends over everything. And it's a package that's included by default with every new Meteor app, just to make your life easier in the beginning. So we'll get rid of it. And we also will get rid of a package called Insecure, which, yeah, with a name like this, you probably don't want to keep it in production. What Insecure does is it lets any client modify your data on the server. So again, it's cool when you're starting out, when you're prototyping, but for a real app, you probably need a few checks and balance. So we'll remove both packages, and everything's broken. So it seems like it's broken, but actually what's happening is our data went missing. All the logic of the template is still here, but it just doesn't have anything to run on. Thankfully, Meteor provides a mechanism to fix this, and it's called publishing and subscribing. And to understand this, let's imagine that your app is a bookstore. So each book represents one document in your database. And defining a publication is basically saying, OK, these books are for sale, but these books aren't. So people have remarked that a bookstore that doesn't sell books wouldn't be a very good business model, but for the sake of the example, let's assume that it exists. So now we have a situation where customers can walk in and buy books among the ones that are for sale. But they're probably not going to want to buy all the books, right? Most likely, they'll just want to buy a subset of your books. And that's exactly how publishing and subscribing works. Publishing is the act of deciding which part of your data is public. In other words, can be accessed by clients. And then subscribing is a client's way of specifying which subset of that data they actually want. Let's translate this into code. So first you have Meteor publish to declare our publication. The first argument will be the name of the publication. And then we have a publish function. So in this case, the publication function takes an argument, which will come from the client. So with the bookstore example, that's like the customers saying, OK, I want these 5 books. So that number 5, this is what client limit will be. And we'll return something that's very, very similar to what we had on the client, except that it takes that client limit argument. So we have our publication, and we can now write our subscription. Really simple. We have the name of the publication we want to subscribe to, in this case, snapshots, and then any additional arguments, in this case, 12, because we want the 12 latest snapshots. And when I run this, yeah, you can see that our data is back, and our pretty images are back as well. So I think that's it for now. There's actually another part to this, but I'll probably gonna get killed if I do it. So I'm going to set all the screencasts up online, and they'll be available at meteor101.com. So check that out in, let's say, a couple weeks. Thanks for listening.
Questions? Yes?
How did you embed the actual app in your presentation? Is that Real.js or something?
So
could you repeat the question?
Yeah. Like the question was, how did I embed the app in the presentation? So this is the only part that's not made with Meteor and doesn't have anything to do with it, but it's interesting. So I'm using Reveal.js with an iframe. And actually, it does have something to do with Meteor, because when I'm running each step here, it changes the commit. It just runs a git checkout for a particular commit. And then since Meteor has a hot code reload, it will detect the change and refresh automatically in the browser. So it works pretty well. It would be even better if the whole thing was Meteor, but for now it's just plain Reveal.js.
Any other questions?
What happens if you've got too much code for the client side to have it down on the client? So say if you have 1,000 points to render a graph, that's going to take a lot of space, and then you've got 2 or 3 graphs like that you want to render. So there's not going to be that much space on the client for that.
So the question was, what happens if you have too much data on the client? Like if you want to render graphs with thousands of points? Well, if it's just points, it's not going to take that much memory. I mean, yeah, usually for most kind of data, you'll want to be careful about that. So limit the amount of data that you're loading in the client. And as you saw here, subscriptions and publications can pass parameters. So you actually have very fine-grained control over the amount of data that you're transmitting. So yeah, usually those problems can be managed. Although for a graph, I think it should be OK in most cases.
What if you have a lot of complex forms that you want to merge people through? Like Webflow or something. Like Spring Webflow.
So the question is, what if you have lots of forms or that people need to go through? In this case, you would probably manage the subscriptions with Iron Router, which is the topic of our next talk.
What an excellent segue. Thank you, Sacha.